Hey, how are you?
Hey, I'm fine, thank you. How are you?
I'm also fine, thank you. So, can we start?
Yeah, sure.
Okay. Can you tell me a little about your project architecture?
Okay. So, my project is in microservices, and earlier we were in monolithic, and we transitioned from monolithic to microservices. And the current project architecture is we have multiple microservices, which are revolving around business functionalities, and the gateway to the microservices is an API gateway. So we are using Zool for API gateway. So whatever requests that are coming to my microservices, they have to go through the API gateway and then they reach the specific microservice. This is one of the features. Then we have discovery service. For discovery service, we are using Console, and before Console, we were using Netflix Eureka. So discovery server is where whenever your microservices start, all of the microservices have to register themselves with the discovery server. So consider we have two microservices, microservice one and microservice two. So whenever they start at the startup, microservice 1 registers itself with the discovery server, and similarly microservice 2 register itself with the discovery server. Now whenever any of the microservice wants to get the URL or wants to discover some other microservice, then it refers to the discovery server to get the URL. So we talk about API gateway, we talk about discovery service, and then we have a load balancing mechanism in our microservices environment. And for each microservice, we are using a separate databases. We are using combination of databases. So we have few microservices which are using relational databases, and there is one specific microservice which is using MongoDB. So this is the overall architecture of my current application.
Okay, and how these microservices communicate with each other?
Yeah. So there are two types of communication between the microservices. One is synchronous communication, and the other one is asynchronous communication. For synchronous communication, we were using a REST template. Now we are using a fine client for this synchronous communication. And in synchronous communication, when we make a call to another service, then we have to wait for the reply. That is the reason it is known as synchronous communication. And we in our architecture we also have a synchronous way of communication using Kafka. So we send an event to the Kafka broker, and then the other microservice listens to that event and performs some action. So here we don't have to wait for the reply for the reply to come in, and that is the reason it is known as asynchronous, and we use Kafka broker for that.
Okay, you mentioned API gateway as well, right? So, what are the features which you have implemented in that API gateway?
Yeah, so in API Gateway, we have implemented several features. One of them is authentication and authorization. Whenever the request is coming in, my API Gateway authenticate the user. So authentication is where we try to find out who is the user. For example, if the user is John, then to identify if the request that is coming in is from John, so that is authentication. And authorization is where what operation John is allowed to perform. So if John is trying to read a file, and John does not have the ability to modify the file, so John is not authorized to modify the file. So in authorization we check this. Okay, so that is one thing, authentication and authorization. The second thing is we check for rate limiting. If there are many requests coming in for performing some operation, and we think those many requests should not be coming in, then we try to perform the rate limiting. And for rate limiting we use 429 as the status code. So authentication, authorization, rate limiting. And one of the thing that we perform in API gateway is combining response from multiple microservices. For example, the client wants results, and to get that result we need to call three microservices. So we from the API gateway we call microservice 1 get the result, microservice 2 get the result, and microservice 3 get the result. Combine all of them and then send back that cumulative result to the client. So these are few things that we performed in API gateway.
Okay. Do you know the design patterns in Java?
Yeah, I know few design patterns. I know solid principles. So I've worked with Singleton. I've worked with strategy builder, and then all the solid principles.
Okay. Can you explain me what is meant by solid principle?
Yeah, the solid principle, the first S stands for single responsibility principle. So your component in Java or your classes, your method should have only one responsibility. It should be performing only single responsibility. It should not be performing more than one responsibility. So that is single responsibility principle. Then O is open close principle. Uh, it mentions that your component should be open for extension and it should be closed for modification. So what this means is when you are trying to add a new functionality to your application, then you should not be changing your existing code. You should be writing new classes to add the new functionality. So it is open for extension. You should be extending and adding functionality rather than modifying the existing logic. So this is open close principle, open for extension and close for modification. Then L stands for list cause substitution principle, which means that you should be able to substitute the subtype. So there is a parent child relationship, there is a parent class, and then there is a subclass which extends this parent class. So you should be able to replace all the parent classes with the subclasses and also maintain the correctness of the program. So when you replace your parent class with the subclass, then still your program should function in the similar manner as it was functioning earlier. So all the parent class should be replaceable by the subclass. This is list cost principle. Then we have interface segregation. Interface segregation is you don't make interfaces with a lot of methods. What you do, you write interfaces uh, which have methods which are very specific to that functionality. Okay, and you don't force the classes to implement the unwanted method. So consider you have one big interface and it has 5 to 10 methods, and one class is implementing this interface. Then that class has to implement all the methods which are declared in the interface. This is not a good practice. Instead, you write interfaces which are very specific, and then that class implements only specific interfaces rather than providing implementation to all the methods. And then we have dependency injection. So dependency injection is where a class wants some dependencies in order to function, so that injection has to be provided from outside. So Spring is an example where whatever dependencies are required by a class, Spring provides those dependencies to the class. So that is about solid.
Okay, fine. Now let us consider I have to implement a Spring Boot application which will perform the CRUD operations. Okay, let us consider I'm going to have an employee application or employee management system where I'm going to add an employee. I'm going to read all the employee details either by ID or I'm going to get all the employee details. Then I need to update the employee as well as delete the employee by their ID. Okay. Now, can you tell me what will be your project structure? Like what kind of packages you are going to declare or what kind of classes you are going to have in your project? So can you tell me all the details about this?
Yeah, sure. So first, I'll try to go to Spring Initializer. I'll create a project. Okay, and what will be the layers in my project? So the first layer is the employee controller, which will write the logic, which I'll use to write the logic related to the API calls. So there I'll write 4 APIs. One will use get mapping. The other one will use post mapping to create the employee. Then I'll use put mapping to update the employee, and then delete mapping to delete the employee. So that is the first layer, controller. From controller, I'll make a call to the service. So the service layer, employee service, will have the logic for all the business related activities. So all the business functionalities will be written in the service layer. and all the transactions will be started in the service layer. Then from service layer, I'll call a repository layer. Okay, so repository layer, I'll use specifically JPA repository, and it is the responsibility of JPA repository to connect to the database. Okay, so controller will call the service will call the repository, and repository will communicate with the database. So at the controller level, I'll use annotation at the rate rest controller. At the service layer, I'll use the annotation at the rate service. And at the JPA repository layer, I'll use the annotation at the rate repository. So this is what I'll use. And a few more things. Now, from the controller, whenever I am sending back the response, if the response is successful, then I'll send the API code as 200. And if for example, while when I get the request and that request is unauthenticated, then I'll send the response as 401. And these are all the status code. And if the user is not, user does not have permission to perform the operation, then I'll send back 403. So these are the few status codes that I'll return from my application.
Okay, and what will be the packaging structure? Like what all layers of packages you will design?
Okay, so I'll use first thing is we use com dot the domain name. So for example, com dot cloudtech dot controller, com dot cloudtech dot service, com dot cloudtech dot repository, and then all the static resources I'll put in the resource, and all the test cases will be in the test folder. And there will be similar structure in the test folder as well to testing all these classes that we have written. And there will be one base package where my application will start, which will be the entry point, and that will be annotated with at the rate Spring Boot application.
Okay, and how do you connect with your database? You said that you are going to use Spring Boot Data JPA, right? So how do you connect this Spring application with your backend database?
Okay, so within Spring Boot application, there is something called as application.properties. And in application.properties, we mention all the required details to connect to the database. What all things we provide? We provide all the database related things. For example, what host we are going to use for database, what port we are going to use, what is the username, and what is the password. So this is known as data source. And we use all these properties and mention host, port, a username and password to connect to the database. And when we start the application, it uses something called as auto configuration, and it creates the data source for us, and that gives us the database connection.
Okay. Now let us consider you are trying to read the all employees from your database. Okay. But there is a API which is taking a lot of time. So how do you manage or how do you handle this situation such that your API should not cause a lot of delay? How do you basically optimize the performance of that particular API?
Okay, so there are a few things which I'll check for. First thing is when client is making a call to the API. So I'll check for the latency. So if the network is taking a lot of time to call the API, then I'll check for the latency. If there is no problem with the latency, then I'll go and check the logic of the API. Okay, and in logic, what I'll check if that API is calling a specific SQL. So if it is making a database operation, if it is trying to read something from the database, then I'll check the query. And in the query, what I'll try to check, am I using some columns in the where clause, or I am using some columns in the join conditions, and if those columns have indexes on them. So if those columns don't have indexes on them, then I'll try to either add indexes on those columns or try to use the columns on which indexes are present, and I'll try to modify the query. So once I modify the query, I'll run it against the database, and then I'll gauge the performance of the API, and then I'll see if the performance of the API is improved or not by adding the indexes, by checking the latency.
Okay, so what is the purpose of indexes?
Yeah, the purpose of indexes is when there are no indexes, then you when you perform some filtering on your table, so your table scan has to go sequentially. It will scan row 1, row 2, row 3, so on and so forth until it finds the row with the specific filter criteria. When there are indexes, so your database query does not have to go and sequentially find from the table. It refers to the index, and based on the index it can figure out where these rows are, and this will reduce the time of that query, response time of the query.
Okay. And you mentioned joins as well. So what are the different types of joins available in database?
Okay, so there are various types of joins. Broadly, joins are classified into two types of joins. One is inner join and the other one is outer join. So inner join is where all the records from two tables, so there is table A and there is table B, and you do inner join, then all the records which are common in table A and table B, only those records will be returned in case of inner join. Okay. In case of outer join, there are two types of joins: left outer join and right outer join, and there is also full outer join. Okay. So in left outer join, you will get all the records from the left table and only matching records from the right table. Okay. And in case of right outer join, you will get all the records from right table and only matching records from the left table. So these are the joins at the very broad level.
Okay. Coming to the Java, which version of JDK you are using?
Now we are using Java 11, but we are doing a lot of coding in Java 8.
Okay. Can you tell me a few features of Java 8?
Yeah, okay. So Java 8, some of the features of Java 8, Java introduced a functional programming. So programming, we have functional interfaces, we have streams, we have Lambda expressions, then we have string joiner, then we have date APIs. Okay, so functional interface is where you write an interface with only one abstract method, and you can have any number of default methods in that interface, but that should be exactly one abstract method. So this is known as a functional interface. And then we have streams. Streams, you get a lot of features related to functional programming using streams. You can do filtering, you can do sorting, you can do group by. Okay. Then we have string joiner. You can perform operations on strings using string joiner. And then there are some date APIs, and there is a Lambda expression. So these are the features of Java 8.
Okay. Let us consider I have to filter certain records. Okay. So there is a list of employees and I need to find the employees whose age is greater than 60. So can you tell me how to do this using Lambda expression or stream APIs or anything, whatever you can do using Java 8 feature?
Yeah, okay. So, what I'll do, I'll consider employees as a list. First thing we do is employees.stream. So this will give me the stream. And then I'll use a filter method on the stream.filter, and I'll provide the criteria. Consider age is one of the instance variable in my Pojo. So I'll use e arrow, and then e dot get age is greater than 60. So this filter criteria will give me all the employees who have age greater than 60. Whatever is your criteria, we can write it in the filter, and dot collect. And in the collect, I want to collect the results in the list. And the return type of this will be a list of employee. And that list will contain all the employees who have age greater than 50 or 60, whatever is the criteria.
No, okay, okay, perfect. And how do you handle exceptions in Java?
Okay, so to handle exceptions, we either use try catch block, or if we don't want to handle the exception, then you in the method signature you write throws, and you give the you give the exception name. So try catch is the mechanism by which we can handle the exception. You can have multiple catch blocks for a try block, and in this case, if you have multiple catch block, then the broader exception should be at the last catch block. So that is how we handle the exception.
Okay, and what are the different types of exceptions?
Okay, so there are two types of exceptions. One is checked exception, and the other one is unchecked exception. So for checked exception, the compiler enforces us to handle the exception at compile time. So we handle these exceptions using try-catch block, as I mentioned. And for unchecked exceptions, these are generally logical problems. When we write a program and there are few logical problems, then unchecked exceptions might be raised. For example, one of them is null pointer exception. And generally, these types of exceptions we can solve by changing the logic of the program. So that is unchecked. Runtime exception, null pointer exception, array index out of bound exception are the examples of unchecked exception.
Okay, apart from try catch, there is one more block which is finally. So do you know about it?
Yeah. So when you want to run your code always, irrespective if the exception occurs or if the exception does not occur, then we use finally block. And for finally block, we write the code to release the resources that we acquired during program execution. For example, in the try block, if you're trying to make a database connection and you want to release the database connection, so that releasing part goes into your finally block. And for example, you open a file in your programming logic, then to close the file, that logic goes into your finally block. So to release the resources, to perform the cleanup activities, all these things are put into your finally block.
Okay, you mentioned that finally block will be always executed, but in certain cases, I feel that I don't need to execute that finally block. So can I do that? Or if yes, how can I?
Yeah, so there are a few cases when finally block is not executed. One of them is when your JVM is terminated. So JVM is terminated using system.exit. So whenever you have a call to system.exit, in that case, finally block is not executed. And there might be few cases where some errors occur, out of memory error occurs, and your program is not able to move forward. In that case also, your finally block might not be executed. So whenever JVM is terminated or whenever there is some error where your program is unable to perform the next steps, in that case, finally block might not be executed.
Okay, but do you know threading in Java?
Threading, yeah, I know threading in Java.
Okay, can you tell me what is a deadlock situation?
Yeah, deadlock is where you have, for example, there is thread one and there is thread two, okay, and thread one is has acquired a lock on object one, okay, and thread 2 wants to acquire a lock on object 1, then thread 2 has to wait, okay. But here what is happening, thread 1 is trying to acquire a lock on object 1, okay, and thread 1 is trying to acquire a lock on object 2, but that lock on object 2 is with thread 2. So here is a deadlock where one thread is waiting to acquire a lock on some object which is held by some other thread, and this thread is trying to acquire a lock on object which is held by. So this is a condition where both the threads are waiting indefinitely to acquire the lock on an object, and they are not going to release the lock they have. So this will result in a deadlock condition.
Okay, and how can I avoid this kind of situation or this kind of deadlock?
Okay, so I have never encountered this situation where how to avoid this, but we don't use nested locking. So by not using nested locking, we can avoid this type of conditions, or we can use a timeout. So if we are not able to acquire a lock for a specific timeout, for example 1 or 2 seconds, then I'm going to release the lock completely. So I can use timeout and I can avoid using nested locking strategy.
Okay, do you know the wait and notify methods?
Yeah, so wait and notify methods are used for inter-thread communication. So, for example, producer consumer problem is a classic problem where we use wait and notify. So when we call wait, it releases the lock, and then we have to notify the other thread. And whenever we send the notification, some other thread comes in, and the scheduler picks it up, and it performs the operation. So wait and notify are used for inter-thread communication.
Okay, do you know the collections in Java?
Yeah, I've worked on various collections: ARRayList, LinkList, um, hash map, concurrent hash map, hash set.
Okay. What is the difference between hash map and concurrent hash map?
Yeah. So hash map is a key value pair, and concurrent hash map is also a key value pair. Both of them are a key value pair collection, but there is one basic difference where hash map is works well with threaded application, and in a multi-threaded application, the hash map might result into inconsistent state in the values that it hold. So here comes the concurrent hash map. The concurrent hash map is suitable for multi-threaded application because concurrent hash map is internally divided into multiple buckets based on the hashing strategy. So for single threaded application, we should go for hash map because it is more efficient in single threaded application. And if you think there is a need for multi-threaded application, then you go for a concurrent hash map.
Okay. And what is the difference between array list and linked list? And when I should choose array list or linked list or array list, how do you decide that?
Okay. So ARRayList, the underlying data structure for ARRayList is an array. Okay. And for linked list, we just set up a link between the nodes. Okay. So if there is a lot of need for insertion and deletion, then we go for linked list, because linked list, when we insert an element, we just change the link reference. Okay. But when there is a need for random access, then we go for array list. So for frequent insertion, deletion, we choose linked list, and for fast retrieval and random access, we use array list.
Okay. So you had mentioned initially that you are using relational database and MongoDB as well. So what is the difference between this SQL and NoSQL type of databases?
Yeah. So for relational database, we have a fixed schema, and when we have fixed schema, we can use structured query language to perform the to retrieve the data, to perform the updates, to delete the data. Okay. And in case of MongoDB or NoSQL databases, we don't have a very fixed schema. So for example, we are trying to store something, and that does not have a very strict schema. In that case, we go and store that thing in NoSQL, and we are very sure that this is the schema that we are going to have. Then we go for relational database and use SQL.
Okay. Okay. Fine. I'm done from my side. Do you have any question for me?
No, I'm good. Thank you.
Thank you. Bye.
Bye.